I just got three things to say. God bless our troops. God bless America. And gentlemen, start your engine!
Hello everybody, my name is Luke Dolan. I'm a sophomore mechanical and aerospace engineering major, and this is our Rocket Dark and Dusty. And fun fact about me is I'm a soccer state champion.
Hi, my name is Jordan Herder. I'm a sophomore studying mechanical and aerospace engineering. I am the flyer of record for Dark and Dusty and the technical lead. A fun fact about me is that I have 3 cats. Go.
Hi, I'm Rex McAllister. I am a junior in computer engineering, and a fun fact about me is I have the most parking tickets in the club.
Hi, my name is Joshua Holmes. I'm a junior aerospace and mechanical engineering student. And a fun fact about me is I'm a twin.
Hi, my name is Zara Zervis and I am a senior here at WVU. I'm studying mechanical and aerospace engineering and I'm the recovery lead for Dark and Dusty. And a fun fact about me is I am on the cross country and track team here.
Hey, my name is Vaibhav Kumar. I am a junior currently pursuing aerospace engineering. A fun fact about me is I love to recruit. That's good.
Hello everybody, we are West Virginia University Experimental Rocketry, and this is our submission to the 2025 Argonia Cup with Dark and Dusty. So as a club, we usually compete in the IREC competition, and we do our test flight in Argonia, Kansas. So since we're going to be there anyway, we decided to build a 2-stage rocket for the Argonia Cup. This will be our first time in the competition.
For the construction of the fins, we used a 1/8 inch G10 sheet. To precisely cut the fins out, we used a CNC router. To ensure the symmetric alignment and better stability, we used a fin jig mount to surface mount the fins on the rocket. The fins are going to be covered with 2 layers of 12K carbon fiber.
So our airframe is 3-inch Wildman filament wound fiberglass. And up here with the nose cone, about 16 inches in length. Right here we have the golf ball blade. That's 14 inches in length. Just below that we have our upper airframe, which is 24, as well as a sustainer, which is also 24. And then down on the booster, we have a 30-inch tube extending from there.
So for recovery for Dark and Dusty, we have 3 parachutes, one for the booster section, a drogue, and a main for the upper airframe section. All 3 of the parachutes are wrapped in Kevlar blankets, which were handmade in lab, and the shock cords are protected with cord protectors, again made of Kevlar, so that way everything is protected from charges and no burning through the chutes will happen. So for our booster, we have a 24-inch Recon parachute. This was simulated to make sure that the spent booster is able to come down without any problems, so that's why a 24-inch was chosen. Then for our drogue parachute, we're also using a 24-inch Recon parachute. Again, everything was simulated just to make sure that our velocity on descent was in a good, safe range. And finally, our main parachute is a 48-inch Recon parachute. So again, they're all the same brand. 48-inch was again just simulated to make sure we're coming down slow enough on recovery, but still make sure that we don't land too far away from the launch site. The whole thing will be held together with 5/8 inch nylon, and Yes, this was just chosen because it'll fit inside of the airframe best, and again, everything's protected with the sleeve protectors.
Dark and Dusty is going to fly on an L-1520 as its first stage. This first stage has a burn time of 2.3 seconds, and then it is going to pull separation. Separation is going to be at 0.5 seconds after burnout. Once separation is successful, the sustainer is going to light a K400. The K400 is going to carry us to the remainder of apogee, which is 15,013 feet. Our time to apogee is 28.5 seconds. Once we have reached apogee, our drogue parachute is going to deploy. This is going to take us down to 500 feet, where our main parachute is going to deploy and take us the rest of the way down to the ground. Our total flight time is 311 seconds.
Alright, the avionics setup in this rocket is set up with tracking using two featherweight GPS trackers, one in the booster and one in the sustainer, so that we can find the rocket, and those both go back to the same featherweight GPS ground station. A featherweight Blue Raven is used as the staging computer in the upper stage. It both controls the main and drogue primary charges for the parachutes, and it also controls the separation black powder charge and the sustainer motor ignition. As you can see in our wiring diagram here, each igniter has a separate set of leads, and the sustainer igniter goes into a pull pin that is configured so that when the pull pin is in, the igniter leads are shunted. When you pull the pin, the igniter leads become connected to the flight computer. The computers run off of a 2S battery with 1,000 milliamp hour capacity, so it has both plenty of current capability and plenty of battery to sit on the pad for a little while we wait for the rocket to be able to launch. The sustainer logic is set up so that the motor will not light with more than 20 degrees of tilt or less than 200 feet per second of velocity. We began our simulation by simulating all of the motor combinations in Python script to figure out which motors we could combine to create the maximum loud impulse, because we wanted this rocket to be designed to go as high as possible. We narrowed down the results based on the fact that we wanted to use our 75mm reload casing and use a 54mm DMS motor in the sustainer, because we don't have a casing for that. And finally we settled on the L-1520T and the K400C, just based on what we found in stock online. For the rocket design, we have a minimum thrust weight of 13.6 to 1, that's right off the pad, and we have a maximum acceleration of 14.7 Gs. We have a predicted apogee of around 15,000 feet, depending on which exact golf ball configuration we end up flying. And for the stability of the rocket, we're running 3.75 calibers off the rod with the full stack, and then that drops a little bit down to 3.08 calibers for just the sustainer. So the rocket stays stable through the entire flight.
WBU.
Virginia.
It's West Virginia. Okay.
Let's go! Mountain!